Hey everyone, welcome to Quantum Cats. Today, we're going to use the simplest examples to explain the most complex thing in tech right now, quantum computing. And while we're at it, we'll take a look at the hungry little giants fighting for a piece of this market. Let's start with the simplest thing imaginable, a coin. A traditional computer is like a coin you've flipped and caught on a table. It can only be heads or tails, one or the other. That's our classical bit. But a quantum computer's qubit is like that coin when it's spinning in the air. In this state, it's neither heads nor tails. It simultaneously holds both possibilities in a superposition. Feeling a bit dizzy? Now, for a more vivid example. Imagine you need to find the one key that opens a lock out of a million keys. A traditional computer would act like a fool, trying each key one by one, in order. It's like being in a pitch-black room with a flashlight, illuminating each key individually. This process is incredibly, unbelievably time-consuming. A quantum computer, on the other hand, can put all a million of those keys simultaneously into a blurry, about-to-open-the-door, superposition state. It's like you suddenly throw open all the curtains. The whole room is instantly bright, and you can see all the keys at once. The question is, how does it know which one is right? A quantum computer doesn't look to filter them. It uses a phenomenon called quantum interference. You can imagine each qubit as a tiny water ripple. The quantum algorithm is like a master conductor, directing the vibrations of these ripples. For all the wrong keys, the algorithm adjusts their wave crests and troughs to cancel each other out, like two ripples colliding and creating a flat surface. This is called destructive interference. For the one correct key, the algorithm makes sure its wave crests and crests perfectly overlap, making its wave grow taller and taller, and its signal stronger and stronger. This is called constructive interference. Through all this work, the correct answer's signal gets infinitely amplified, while the signals of the wrong answers are almost completely erased. In the end, only the right key remains. It doesn't eliminate wrong answers one by one, like a traditional computer. From the start, it uses a parallel mindset, leveraging superposition to process all possibilities at once, then using the magic of quantum interference to make the correct answer pop. So, for exponentially difficult problems that a traditional computer would take tens of thousands of years to solve, a quantum computer can perform calculations on a massive scale, even instantly. The core of quantum computing is the leap from the linear, one-by-one thinking to the parallel, simultaneous thinking, which delivers an efficiency that's truly unprecedented. Now, as cool as that sounds, a quantum computer isn't perfect. Its biggest enemy? Outside interference. You can imagine you're a scientist meticulously adjusting those water ripples, but someone outside the lab is constantly throwing pebbles into the pool or making a lot of noise. These disturbances directly mess up your carefully designed interference patterns, turning your results into a complete mess. This is why current quantum computers have to be placed in an extremely cold environment, near absolute zero, to block out all those tiny thermal and electromagnetic noises. And building that environment is incredibly complex and consumes a massive amount of energy. Not to mention, quantum computing has its own unique programming languages and algorithms that are completely different from what we're used to. This means we need to train a whole new generation of experts who know both quantum mechanics and computer science, and that's a very scarce resource right now. So, a quantum computer is definitely not here to replace your phone or your laptop. It's much better suited for very specific, difficult tasks, like rapidly simulating the interactions of dozens of atoms to find the most effective molecule in drug discovery, or instantly calculating the optimal route for millions of trucks in the logistics industry. Despite the challenges, this field is packed with major players. First, let's talk about the tech giants you already know. Google and IBM are both on the superconducting quantum computing path. Google is known for its 2019 quantum supremacy claim, while IBM is a step ahead in hardware development and cloud services. Amazon, the cloud services boss, has chosen a cloud integration approach. It doesn't build its own hardware, but integrates other companies' quantum computers onto its cloud platform, letting people use them as easily as ordering takeout. Microsoft's path is the most unique. It's betting on topological quantum computing. This technology is theoretically capable of solving the problem of qubit fragility from the ground up, but the difficulty is extremely high, and it's still in the research phase. Honeywell, now part of Quantinuum, is known for its ion trap quantum computing technology, which is characterized by its high precision and good connectivity. Seeing that the giants are on completely different paths, are you confused again? What's the real difference? Let's break it down with another example. A universal quantum computer is like the concept of a car, whose function is to carry people anywhere. Superconducting technology is like a gasoline engine, one way to make a car work. Ion trap technology is like an electric motor, another way to make a car work. And a quantum annealer is like a train. Its function is also to carry people, but only on a predetermined track. While both can transport people, a train has a clear route. It can only solve optimization problems, while a car can choose its route freely. It can solve universal problems. A quantum annealer is highly efficient on its track, but it can't compare to superconducting or ion trap technology in terms of versatility. Besides these giants, there are a few independent, publicly traded companies in this field that we should talk about. IonQ Inc., ticker IonQ. Founded in 2015, it plays the ion trap game, in the same family as Honeywell. Its technology is known for high precision and long coherence times, making it like the Swiss watch of the quantum world. Their tech has already been applied to things like optimizing flight loads and vehicle fleets. Of course, as an early-stage company, its valuation relies heavily on future potential, so some critics say they're all sizzle and no steak. D-Wave, QBTS. Founded in 1999, you could call it the granddaddy of the quantum world. It specializes in quantum annealing, acting like a specialist doctor who only knows how to find the optimal solution. While its technology is controversial, it was indeed the first company to commercialize a quantum computer, for example, by helping Volkswagen optimize taxi routes. Rigetti, RGTI. Founded in 2013, it follows the same superconducting path as Google and IBM. It's a full-stack company that handles everything from chip fabrication to software development. Rigetti also has projects in finance and AI. As a startup, it faces the same major technological and commercial pressures. Finally, let's look at the financials of these three companies. According to their Q2 2025 earnings reports, IonQ's revenue was $20.7 million, up 82% year over year. D-Wave's revenue was $3.1 million, up 42%. Rigetti's revenue was $1.8 million, down 41.9%. In general, all three are still in a high investment, high loss early stage. But their financial data also shows that the quantum computing industry is moving from pure R&D to commercialization. So, what role does quantum computing play in the AI revolution? We can describe their relationship as a mutual journey. First, AI is the ultimate accelerator for quantum computing. AI's new capabilities are being used to solve quantum computing's most difficult problems, the noise and errors that make quantum computers as fragile as glass. If we used to manually debug quantum computers, now, with AI, we can let them learn to become more stable and reliable on their own. This means we can build more powerful quantum computers faster and truly take them from the lab to the market. Conversely, quantum computing is the ultimate client for AI. As AI models become more complex, their computational needs are growing exponentially. It's like a highway where traffic is about to come to a standstill. You need a brand new, wider road. A quantum computer is that superhighway prepared for AI's future. It can solve extremely complex problems that traditional computers can't handle. When AI hits a wall, quantum computing will be the ultimate tool to give it infinite power and open the door to a new world. So, these are no longer two separate tracks. They are a shared destiny. AI is helping quantum computing run faster, and quantum computing is providing infinite possibilities for AI's future. That's all for today's talk. Thanks for listening. This is Quantum Cats. See you next time.